So I am from Lodha. We are a leading developer in the country, and we are quite focused on sustainable urbanization. And I'll tell you the reasons why. Uh, starting, uh, I'll start with our LC3 journey. I mean, we were introduced to this thing by our partners at RMI and Professor Bishnoi. We were, by that time, we already had our long-term net zero commitment with SBTI. We were the first real estate company to do so. And in that process, we realized that one of the things that is most important in decarbonizing, especially embodied carbon, is basically concrete. It is most of it is concrete. So we made our commitment sometime in 2022 that we are open to try out LC3, and then we waited and we waited and we waited, and nothing happened. And then finally, in this process we got into an MOU with IIT Delhi where they were to support us, and then again we got some material from JK Cement which we tried, and it was evolving at that time. And then again we waited and waited, and finally this year the material was produced. The day it was being produced, we were there. Love is standing there. He was there. Harsha was there, and we gave our order the next day itself. And then we used it in a small patch on a road project in our development called Palava. And now we are at a situation where we'll see what more can we do with it. Having showed you this timeline, I think what is most important is that why are we doing it in the first place? Why is it even needed? So this is that hockey team of India, which used to win all the gold medals, and then something happened that we stopped winning those medals, and we are getting some consolation bronzes in last 8-10 years. So what actually happened was that the turf had changed. So the growth turf that the Western countries had, all these developed economies had, was built on high emission, high energy, inefficient usage, and therefore their economies could grow. Now we have reached at a point where we are trying to leapfrog from being a low income economy to a high income economy, and we do not have that turf. The turf has changed. We cannot have less efficient construction, high energy consumption, and so forth. So we are at that point now. Either we take this chance of finding this new turf and embracing this new turf and growing, or we get stuck and we reach nowhere. Those same old formulas will not help us grow. India at this time stands at a amazing place where we are one of the fastest growing economies, leading fastest growing economies. We want, and we are probably in a state to become a mid to high income economy in next few decades. As a real estate company, we interpret this situation as, and lots of reports also say that close to 100 million people 100 million households will become home ownership capable. That means close to 500 million people will move from these towns and villages to cities, and that is what will get built in the coming decade and a half. The problem is that if that will happen, and the cities will not actually look like this. These are our projects, but they will not. What we end up doing is something like this. And this is what we need to overcome. Because on one side, we think that urbanization that goes along with the economic growth can become a booster for the economy. But this is a drag. This is such a drag that a country can miss their once in a lifetime growth opportunity. So if India has to grow, India has to grow in a manner which is energy efficient, material efficient, and which is climate secure, energy secure, and so forth. Else we will not grow at all. And so that is the precise reason why we are trying out these new things. Let's see what clicks. So as I said, this is the problem. We have been working on a sustainable urbanization template in the name of a city that we are developing called Palava. It's a It's a model city spanning 4,500 acres. It will, at its ultimate build out, it will have a population of 1 million people. We have built enough phases that the current population of this development is close to 200,000, and it's a multi-decade, multi-generational commitment from our side. We'll continue to do that. These are real photos from the city. These are also real photos from the city. And then what else we have started doing is that we have started using, first of all, we were building the city on a template, and now we have converted it into a living lab in partnership with our, in Lodha Net Zero Urban Accelerator with our partners RMI and also IIT Delhi and others on various initiatives. So what we do is we try out stuff. And the idea is to pilot and scale. So whatever works, we'll scale. And LC3 is one of them. The photo that you see in the bottom is where we were pouring LC3 on the road. And having talked about concrete is actually a very big impact area in the in embodied carbon. So what has happened is that we know that urbanization and density and going taller will solve a lot of problems, and we have, in fact, we now know how to go tall. Even we are building now 2-kilometer tall buildings in the world. So going tall and becoming energy efficient is not so much of a problem, as much as is reducing the embodied carbon, the carbon that is in the materials. And the baseline in India is close to 1,000 kg per square meter, and we need to find a way that just to significantly bring down. We as an organization is working at a benchmark which is close to, say, around 400, and we now know that by operating certain levers, we can bring this down to even 200. We recently published a study of close to 10 odd buildings, all the way from 10 stories, 15, 20, 25, 30, all that we have been building, including composite buildings, showcasing the embodied carbon that the buildings have. We have also listed down our assumptions where the EPDs or the embodied carbon coefficients are not readily available. So the idea is, so we have already come down from, say, 1,000 baseline to 400, and how do we come down further? We know that most of the embodied carbon lies in just these 3 materials, and if through design and these 3 materials we can do something, we can bring this down significantly. So 2/3 of embodied carbon is just in steel, concrete and aluminum. So if somehow we are able to attack the problem, we can sort of solve it. And the problem is very much like this burger. It's a fat burger. Now how to make it more healthy? Sometimes what we end up doing is just get a better bun and just get a better patty. That's not going to solve it. And that's exactly when we only talk about concrete mixes, let's try to do something with the mix and the whole problem will get solved. It won't. So we'll have to have a paradigm shift where we maybe use the same materials and convert this whole thing into a salad bowl which has much lesser number of calories. So that's a sort of an approach that we have taken. And we are working significantly on the aspects of design to bring down the embodied carbon. We recently wrote something on material minimalism where we have listed down the levers that we are utilizing to lower the material intensities in a building. So we have started, so most of our buildings are of regular geometries. The loads directly get transferred to the foundations. We, at all costs, we avoid basements, we avoid transfer structures, we avoid cantilevers. All these things sort of add up to reducing the embodied carbon in a building. And I think that the graph that you saw on the previous page, most of the wins are basically from design, because design is what you do today and you get the benefit today itself. And these baselining studies are also part of that exercise. Next is concrete. By concrete, it is not only LC3, it's basically low carbon concrete. So any concrete mix that can bring down the embodied carbon significantly is what solves the problem. And currently the clinker factors, which are really very high in the concrete that we use, we have to just target them, push it to a level that is at least whatever is feasible at this moment is something that we should achieve across our projects. We are working also on steel and aluminum, but for this at this moment I'll not go into the details. We feel that if we are able to get the clinker factor down, and if we are able to get the embodied carbon emission of steel and aluminum also down to these numbers, and continue to do an efficient design, we will probably be able to bring down the embodied carbon significantly to the tune of 200 kg per square meter for tall buildings. So we are doing all these experiments and all these trials are basically leading up to these targets. So this is out of a model where we see that across those 10 buildings, the embodied carbon can actually come down to 200 if those numbers are achieved. I'll end by, just showing you one example of. So we did a building with the GGBS fly ash composite low carbon cement, which was with 50% cement, and it actually could bring down the embodied carbon significantly, close to 30%. This option, while it may not be applicable for the entire country, plus whatever we are doing with LC3, where maybe GGBS will not be available, we need to just somehow cut the use of OPC and use these SCMs to the extent that we can. One very important lesson that we have from this experiment for the LC3 trials that we are doing is that it took us several years to reach here, because first we had to convince the teams. They started on a multi-story building, they first did a multi-level car park, then they got the confidence, then they ventured into a building and so forth. Despite the fact that those mixes were working. I think LC3 will also be subjected to this sort of a challenge, that while we have achieved those mixes, developing confidence on those mixes and using them at scale will be a challenge that we will have to overcome. We have already put it on a project in a road. I think we'll have to do it on some short structures, some in foundations, and then possibly some top floors in a building, and then ultimately an overall building. This is a multi-year journey. So it won't, the simple fact that LC3 exists, and we as you saw in the first slide, that there was a timeline of thinking about it and pouring it on site, there is still far to go. So while, I was patient today on the flight, but you have been patient for so long, more than a decade. So what we have been doing is a very little thing, and we will always be there, not only for LC3, but any other solution that you would want us to try in our living lab and at Palava. We'll be very happy to do that. Thank you.